So hi everyone and welcome to the vodcast on exercise 16b. Let's get this show on the road. You would have noticed the title of this was the 68, 95 and 99.7 rules. Well, what are we referring to? Well, you might already be familiar with this. Probability mean minus 2 standard deviations less than or equal to x less than or equal to the mean plus 2 standard deviations is approximately equal to 0.95. That's the so-called 95% rule. So we say that we expect that 95% of the values will lie within 2 standard deviations of the mean. Let's rub that out. So the 68% rule is like this. Probability that the mean minus 1 standard deviation less than or equal to x less than or equal to the mean plus 1 standard deviation is approximately equal to 0.68. So that we're 68% sure that the values will lie within 1 standard deviation of the mean. Okay, let's look at this question. So looking at this question here, if the mean is equal to 0 and the standard deviation is equal to 1, we're saying that 68% of the values are going to lie within 1 standard deviation of the mean. So we can use the symmetry of the graph to answer this particular question. So it wants to know what percentage is going to lie in this region. Well, here's what we know. There's symmetry, so we know that that section plus that section must be the same. We know that the area under the whole graph is equal to 1, also known as 100%. So this means that these two shaded areas are found by doing 100 minus 68, which is equal to 32. Now in the meantime, it means that this one plus this one is equal to 32. So to find which is just in this little section here, we divide this by 2, and that gives us 16%. So we can say that 16% is going to lie in this region in here. So rubbing that out, the next part of the question says what is the probability that x is less than 1? Well, remember we've just worked out that this is 0.16, so the area going back this way must be 1 minus that. So 1 minus 0.16 is equal to 0.84, and that's the answer. So let's have a look and see how it broke down with the actual written answers. There's our 16% before, and here's our 0.84. Okay, let's go to the next slide. So this one is our very familiar 95% rule. So probability mean minus 2 standard deviations less than or equal to x less than or equal to the mean plus 2 standard deviations approximately equal to 0.95. So this is our so-called 95% rule. So we're saying that 95% of the values are going to be between or within 2 standard deviations of the mean. Okay. Question here says what percentage lies in this region. So it's a similar question to the previous one. This section here and this section here are symmetrical, so they're both going to be equal to the same. So to find out what the sections are, we first do 100 minus 95, and that gives us 5. So this region plus this region is equal to 5%. To find out what that region is equal to, because they're both the same, just divide that by 2. And so it's 2.5% is in this region here. Next part of the question says what's the probability x is less than 2? So we're going to do 1 minus 0.025, and that's equal to 0.975, and there's our answer. Let's have a look and see how that looks in nice neat writing. There's our 2.5% that we already had, and there's our 0.975 that we had as well. And then we get to the 99.7% rule, and so what we're saying there is the probability that the mean minus 3 standard deviations less than or equal to x less than or equal to the mean plus 3 standard deviations is equal to 0.997. Now obviously that's almost 1, isn't it? And so therefore we say that it's almost certain that our values are going to lie within 3 standard deviations of the mean. So this question is just really an application of what we've just seen. So when it's asking for between which two values will the 68% of the values lie, what we need to do here is the mean minus 1 standard deviation up to the mean plus 1 standard deviation. All we need to do is to find out what the mean and standard deviations are equal to. So the mean is equal to 100, standard deviation is equal to 15. So 100 minus 15 is 85, 100 plus 15 is 115, and therefore the numbers that we're looking for are 85 and 115. Let's rub that out. In the second part, where we've got 95%, we're going to do the mean minus 2 standard deviations up to the mean plus 2 standard deviations. We already know that 1 standard deviation is 15, 2 standard deviations therefore are 30, so it's 100 minus 30 and 100 plus 30, and that's going to give us 70 and 130, and that's the answer to the second part. Let's rub that out. And the last part, our 99.7%, so here we're going to do the mean minus 3 standard deviations up to the mean plus 3 standard deviations, and so that's going to be 100 minus 45 and 100 plus 45, and that's going to equal to 55 and 145, and that's the answers that we see down here. Okay, so in this question we're using the same parameters. Mean is equal to 100, standard deviation is equal to 15. We've got to find what percentage of scores lie above 115. Now the eagle-eyed amongst you would notice that the 115 could also be written as 100 plus 15. In other words, the mean plus 1 standard deviation. And as soon as we think of the mean plus 1 standard deviation, we're thinking of our 68% rule. Let's see how that works. Yes, so we can use the 68% rule as 115 is equal to the mean plus 1 standard deviation. And so what the question's asking for is, what's the probability that the score lies above 115? So we want to find out probability x is greater than 115. It does say percentage though, so we need to express our answer as a percentage. And in order to do this, we go back to what we learnt previously. So that's our 1 standard deviation. As you might recall, the area which was in here was 0.16 or 16%. So 1 standard deviation, that's got the same place as that 115 we had before. And so we can therefore just answer the question straight away. And the answer is 16%. And so in this one, we've got a diagram which may prove to be useful. Remember, we know if we've got the mean plus 1 standard deviation, the mean minus 1 standard deviation, we know that in this whole area here, we've got 68%. Because of the symmetry of the graph, we can say that the area in this little section must be half of that, which is 34%. And so the area in here must also be 34%. Okay, let's just wipe that out for a minute. And now let's put up the nice neat writing so we know that's going to be 34%. Now, we're going to try and get this next part in here, which we're going to try and work out an expression for these. Remember, this is our mean minus 2 standard deviations, and that's the mean plus 2 standard deviations. Remember, we know that 95% of the values are in there. So we've got 95%. Meanwhile, we know that what's in here is 68%. So we're going to minus 68 from that, and that must leave us with what's in that region and that region. So let's do our 95 minus 68, and that's equal to 27%. Now we're going to divide that by 2, because that's going to tell us which each of these is equal to, and that's equal to 13.5%. So we can now say that section there is 13.5%, and that section there is 13.5%. Okay, let's get rid of that messy writing. Let's show us a nice neat way of doing it. And there's our 13.5%. Now, in a similar way, we can work out what's in the lighter green region as well. Turns out it's 2.35%. Now, the reason why this diagram might be useful is because a question might say to you, for example, what's the probability that it's between the mean plus 1 standard deviation and the mean plus 2 standard deviations, and you will know, because you've got your little diagram memorized, that the answer to that would be 13.5%. So this may save you a little bit of time in the long run. And here we have an example of where we might try and use that information. So the example is, we know the mean is equal to 80, the standard deviation is equal to 10, and we've got to try and find the probability the values are between 70 and 100. Okay, let's draw a nice little diagram and see what that looks like. So the 70 is going to be the mean, 80 minus 1 standard deviation. So the 70 is going to be here, the mean minus 1 standard deviation. This is our lower level, so it's going from 70 up to 100. Now 100 is here, and it's the mean plus 2 standard deviations. So that if we wanted to find what the area in here was equal to, all the way up to there, it's a matter of adding 34, 34, and 13.5 together. Let's see how that looks. So probability 70 less than x less than 100 is equal to 0.815. Similar question might be, I'll just rub this out here, if we wanted to find out the area between 90 and 100. So here's 90, here's 100, and we can see just by looking at that the answer is going to be 13.5%. Okay, so here's a little question from the text. Now, Michael's going around bragging because he's done a test and Cheryl's done a similar test, but they haven't done exactly the same test. And what they really want to do is to find out who's really done better. So let's see what happens. Michael scored 85 on the maths section, and we know that the mean of that particular test was 78 and the standard deviation was 5. So keep that in mind. Mean was 78. Standard deviation was 5. Cheryl, on the other hand, sat for a different test and she scored 27. Now, when you first look at it, you might say, I laugh in your general direction, Cheryl, because I got 85 and you got 27. But in order to compare them, what we need to do is to convert these into z-scores, which are the scores you get for a standard normal distribution. So our task is to try and compare them by converting both into z-scores. Now you might remember that our rule for converting into z-scores is x minus the mean over the standard deviation. So if we consider Michael, his z-score, well now let's see, he got 85, and the mean of that test, that was 78, wasn't it? Divided by the standard deviation, and the standard deviation was 5. Okay, 85 minus 78 is going to be 7, so that's 7 on 5, which is roughly equal to 1.4. Well, it's exactly equal to that actually, isn't it? Now, let's consider Cheryl. Now, Cheryl, we can also convert to a z-score. Now, the higher the z-score, the better you've actually done. So what we're trying to do is to see if Cheryl is going to end up with a higher z-score. Let's have a look and see what happened. Now, what did she get? She got 27, didn't she? Let's minus the mean. Now, the mean was 18. Ooh, I'm getting a good feeling about this. But the standard deviation was 6. Now, 27 minus 18, what's that equal to? Let me think. That's going to be 9, isn't it? So it's 9 over 6, which is equal to 1.5. That's 1.5. So look, that one has got a higher z-score than that one. The higher the z-score, the better the person's done. So Cheryl can now say to Michael, I got a better score than you, mate. Suffer. There it is. This is just showing the same thing, showing that Cheryl did in fact beat poor old Michael. And yes, so as already confirmed, the higher the z-score, the better, and so Cheryl did better. This one's going to be a similar story. We want to find out which mark was better, the biology or the history mark, so we need to convert both of these into z-scores to get a bit of an idea. As it turns out, the biology one was 1.734, working, you can see down here. and the history one was 0.902. Remember what we said before? The higher the Z score, the better the performance of the student. So the student has performed better in biology than what they have in history. And so that brings us to the end of exercise 16b. Well, it's the end for me, it's a start for you, because now you've got to do a little bit of work. So look, that's all for now, and could I just say, may your maths be good maths, and bye for now.